mass of proton is equal to mass of proton is equal to mass of proton is equal to okay. So mass of proton is equal to 1.00727 U, which is equal to 1.67262 into 10 power minus 27 kg. Mn is equal to 1.008660 into 1.6749 into 10 power minus 27 kg. Okay. Now we found that what is that? Nucleus of the size of the nucleus. So R equal to R0 A. So if I pass this A to here, what will happen? This side. Huh? R by R0.
R0 equal to R divided by A.
R divided by A into 3, A root 3 into R0. So now we have to find the size of the nucleus. Size of the nucleus is what is that? It is a size of the nucleus is radius. So radius of the nucleus is equal to R0 into A 1 by 3. R equal to R0. R equal to R0 A 1 by 3. There is mass energy. Mass energy. Mass energy is, do you know what is this equation? E equal to mc square. E equal to mc square. What is this equation? This is famous equation, theory of relativity. Theory of relativity. For this equation only Einstein got second Nobel Prize. Then what for first Nobel Prize he got? Huh? Huh? What is the first Nobel Prize he got? Yesterday we discussed theory of photoelectric emission. Theory of photoelectric emission. Okay, something. This nucleus, this is electron. This is binding energy nu. This one is nu. Okay, if the nu is greater than binding energy. Yeah. Then if nu is greater than phi is greater than binding nu. Not agree. What is this famous law? This law. This is law of photoelectric effect. This is for law only. This Einstein got Nobel Prize. This is the first prize. This is second prize. Theory of relativity. Theory of relativity. Okay, so this theory of relativity says that E equal to mc square. What it tells that? E is equal to delta m c square. So if this mass varies, what will happen automatically? Energy will dissipate. If this mass varies, the energy will be dissipated. Energy means energy can be obtained. If you change the mass, okay, change the mass, you can find that energy you can obtain the energy. Example, I am taking you can take yeah.
By changing the mass, we obtain the energy.
By changing the mass, you can obtain the energy. Then changing the mass, how I can write? M2 minus M1. Okay. Example. You have to tell me. If you tell, you have to tell me. You didn't write it. You write it finished? Okay. Just tell me what is 2 examples you tell me. If you understand this thoroughly, just simple example you tell me, I will tell it's right or wrong. You understand the concept. Delta m c square. See what is c? C is constant velocity of the light. Velocity of the light. Velocity of the light. Okay. So now you have to tell me to give 2 example and tell me. Give just 2 example and tell me. That means the decrease in the mass will lead to the change of the energy. It will lead to the energy you obtained, will lead to the output of energy. So change of the mass. What is the change of the mass and what is the energy obtained? You need to examine practically what we are using it. The change of the mass, okay,
Change of the mass.
will lead to the energy. Will lead to the energy. Will lead to the energy. So change of the mass is written as, I can write as m2 minus m1. Okay. So what is m2 then? Final minus initial. That's all. Okay. I can write. No, I don't want to write m2 by m1. I'll write as m1 mf by mi. Okay. Okay. What is that? What is that example? If we understand that example, that means you understood this equation. Okay, okay, I will tell now myself.
Photoelectric effect.
No, that's different. That's law is entirely different. Photoelectric effect. This law is different. This law is different. Law. The law means what? It states something that will tend to form the thing. That is that law is photoelectric effect. That's different.
Electron revolve around the nucleus.
Electron revolve, how will it related to the energy and how related to the mass?
When we apply some energy, they only emitted to next orbital.
Okay, okay. That's nowhere related to this. What you are telling, that is nowhere related to this. Okay, I will tell. Okay, I want hot water. Okay, what I will do? I will switch on the gas stove. Okay, good. Switch on the gas stove. I am taking some 1 liter of water. That's sufficient. I need some hot water for drinking. Some few liters I am taking. 1 or 2 liters you can take. Just take some whistle, pour water and keep it in there. Switch on the gas. Keep it. Okay. Then I am another option is there. No. What is another option? I can take something coal. Yeah, coal. Take some coal. Take some coal. Okay. Put it. Burn it. At same 1 liter, the same content, same whistle, same water. Take it. Thing. So leave it for half an hour. This one if you take half an hour means this will take obviously 1 hour I think. No, time will only the difference. So this is the example. At least I given the clue. That's all. 50% clue I given. Now you tell me how will it relate to this. You understand the concept? I given clue. 50% is answer I give.
If we apply the heat, the water will.
Yeah, water will boil. That only I told you. You just repeating what I told you. What is the concept? This concept is the example of this. On what way it is related to this? You understand the question now, at least. I understood the concept. I given the answer also now. 50% answer only this. 50% answer is.
We change the mass and increase the energy.
What mass?
We obtain that energy, heat energy.
Okay. Which mass?
Mass of air.
Huh?
Mass of air.
Mass of? Which mass?
Mass of water.
Mass of water. No, that is not a mass. Mass, see, we are getting hot water, right? After half an hour. This one is half an hour. After this one is 1 hour. We are heating it. We are getting the hot water. The hot water remains same. But what is the change of mass here? So the change of energy is what here? Change of energy. Which energy we are? This is the energy. Energy is related to delta m. What is the energy here? What energy first we got it here? Heat energy. We have supplied heat energy. Okay, that energy we got it here. What is the change of mass? Change of mass is gas. Gas. Okay, the gas we are taking it. We are heating it for half an hour, right? No, I'll take it as 1 hour. This one is 1 hour. This one is 2 hour. You keep. That's only a difference. Just some difference. This is 1 hour. This is 2 hour. We are taking some gas, heating it for 1 hour. So what is the initial volume and what is the final volume it will be after some time? That is the first one, this one. MF minus N1. Some gases we are supplying for continuously how many hours? 1 hour. So something there will be at least some percentage of the gas will be decreased, right? So that's the initial weight. This is final weight. So the final initial weight the initial weight will be higher. Okay? Final weight will be lower. So it should be Mi minus M1. See, you know, right, when the gas cylinder, what is the weight of gas? When you receive the gas cylinder, it will be written the gas cylinder, it will be around 14.5 kg. 14.5 kg, okay? We are continuously using it for 1 hour. Let us assume we are using for 1 hour, its value is 14.5. After 1 hour, how much gas do you think that it will be decreased? After 1 hour, approximately.
2%.
So something, not 2%, it will be approximately 1%, 1.5 kg after 1 hour. So initial value is 4.5 kg minus 13. So change of the mass is how much? 1 point? That is okay. Something decreasing. So this is the mass of the gas that is decreased. This is the energy is heat energy. This is the mass that is decreased. So in the similar way, coal you take. What is the kg you will take? Let us assume you are taking 1 kg of the coal for heating in the water cylinder. After 2 hours, what will be there? Now it will be nothing will be there. It's only dust will be there. So the total mass will be 0. Total is 0. Total mass is after that it will be 0. Initial mass will be 1 kg. Let us assume. So after 2 hour heating is 1 kg reduced to 0. So it should be 1 minus 0. It should be 1. Here it is 1.5 kg. Here it's 1.5. Change is 1.5. Here it is 1. So now you understood the concept.
Yes, sir.
Okay. Yeah, you can take this. You taken this? Okay. So two examples you have taken it. While heating the gas and heating the coal. Two examples you have taken it. EBN is equal to EB by A. EB is a binding energy. EBN is a binding energy per nucleon. And N is the number of nucleon. What is per nucleon?
1 nucleon.
Number of proton plus neutron. Nucleon is made up of proton plus neutron. The proton plus neutron of 1. So the number of per nucleon. For per nucleon it is 1. For 1 it is, this means for example the per nucleon Per nuclei means the proton plus neutron will constitute the nucleon. Okay, per nucleon means for one nucleus, for one particle, this is taken as a one nucleus, or you taken as a per nucleon or one nucleus. For one nucleus it is like this. For number of nucleus, that is the number of nucleon. That means number of nucleus, how many it is. If it is 1 means okay, for n means you can take it as n. So EBN is equal to EB by A. Okay.
What is the name of this?
Nuclear binding energy.
Interbinding energy.
Nuclear binding energy. Nuclear binding energy. Okay. So based on this observation, first point is the force of attractive. The force of attractive is sufficient to produce mega electron volt per nucleon. Mega force of attraction is sufficient to produce
Mega.
is sufficient to produce binding energy of mega electron volt per nucleon. Mega electron volt per nucleon. So what is that? Force of attraction is sufficient to produce mega electron volt per nucleon. The binding energy of around 30. No, the binding energy less than 50. Binding energy of less than 50. So the binding energy of three types: 50, short, medium, long. The binding energy of three types: short. No, right. The binding energy of three types means how will you write? Binding energy of three types: short, medium, long. Short, medium, long. For short it is for short it is 50 mega electron volt. For medium is 50 to 100 electron volt. For greater than 100 means it is a and Consider consider two light nuclei. Now 2 point is over. No, this is third one. No. 2 point. What is the first point I told?
The force of attraction is sufficient to produce mega electron volt.
Okay. Two light nuclei. Two light molecule now forms the heavy molecules. Two light molecules forms the heavy molecules. Two light molecules forms the heavy molecules. So the binding energy of the heavy molecules is greater than the binding energy of the light molecules. Binding energy of the heavy molecule is greater than the binding energy of the light molecules. Greater than light molecules. So now I am taking two light molecules A and B. So I am for A and B united to form a B. So which will have a high binding energy now? B will have a high binding energy compared to A. Over?
Yes, sir.
Next is nuclear force. Nuclear force. Nuclear force. Huh? Excess? No excess. I didn't tell excess. Just nuclear force. That's all. Nuclear force is stronger than Coulombic force. Nuclear force is stronger than the Coulombic force. Coulombic force. Then the nuclear force between two nucleon. Nuclear force is stronger than the Coulombic force. Then nuclear force is, falls to 0. The nuclear force between the two nucleon. Nuclear force between two nucleon falls to 0 if the distance is greater than few femtometer, if the distance is greater than the femtometer. Femtometer. What is femtometer? So this is nucleon, okay. Nuclear force is stronger than the Coulombic force, okay. Okay, forgot about that law. Second law tells us nucleon is nuclear force is stronger if it is, what is that? What I told you? Between two nucleon. Tell me.
Falls to 0.
Between falls to 0 if it is distance is greater than.
Femtometer.
What is femtometer? Femtometer is 10 power minus 15 meter. So the nucleon proton distance should be less than 10 power minus 15 meter. If it is more than 10 power minus meter, what will happen?
It will fall to 0.
So the force is 0. That's all. Nuclear force is 0. That's all. It has no interaction, nothing. But if it is less than if the distance is less than between 10 power minus 15 meter means less than 10 power 15 meter means what?
It has the interaction.
It has the interaction. It has the interaction provided the distance between them is 10 power. You understood this concept or not? No? You didn't understand, no?
Sir.
See, the what is the nucleus made up of?
Proton plus
No,
neutron.
nucleus is made up of
Proton plus neutron.
proton plus neutron. So 3 types of possibilities there. Neutron, proton and proton. So this proton distance, for example, you can take neutron proton itself. This itself we can take. We don't want that. This is proton, this is neutron. No, this is neutron, this is proton. Distance is 10 power minus 15 meter. Okay. If it is exists only, then nucleus exists. Okay. Suppose let us assume I am going for second option. Here the proton, here the neutron. The distance between them is, instead of 10 power minus 15, I can put it as a 10 power 16 or 17, something like 10 power minus 20 meter. Now what will happen? What is the first you see the distance between neutron and proton. Here what is the distance between neutron and proton? Neutron and proton? 10 power minus 15 meter, which is femtometer. This one is 10 power minus 20. So this one is greater than the femtometer. So the distance is between the neutron and proton is 10 power minus 20 meter, which is greater than 10 power minus 15, which is femtometer. So here force of attraction is
0.
Force of attraction is 0. F is equal to 0. That's all. This is what I explained to you.
Yes, sir.
Okay. Then the nuclear force between nuclear force between the nuclear force between neutron neutron, neutron proton, proton proton is same. So all three has the same force, same force, same force. The interaction between the force between neutron neutron, force between neutron proton, proton neutron is same. Huh. So what we get? Same force. Okay. The neutron neutron, neutron proton, proton proton. They will have the same force. Force of interaction. Same force of same force of attraction. Same force of attraction. Okay. Now radioactivity. 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 The material is said to be radioactive. Radioactivity. The material radioactivity. The material is said to be radioactive. The material is said to be the material is said to be radioactive. Is said to be radioactive. Is a type of nuclear phenomena. Is a type of nuclear phenomena. Is a type of nuclear phenomena by which unstable nucleus undergoes nucleus undergoes by which the unstable nucleus undergoes to a stable nucleus, by which the unstable nucleus undergoes to a stable nucleus. Nucleus undergoes to a stable nucleus. So three types of radioactive material is three types of radioactive decay is three types of radioactive decay is alpha, beta, gamma. Three types of radioactive not material, decay. Three types of radioactive decay. Three types of radioactive decay is alpha, beta, gamma. So in alpha is which charge? Positive charge. Beta is negative charge. Gamma is neutral. Okay. So in this thing, law of radioactive decay. Law of radioactive decay. Law of active decay, R equal to lambda n0 E minus lambda T, R equal to R0 E minus lambda T. So decay rate, R is decay rate at certain time T. Then N is the number of undecay molecules. What is undecay molecules? Number of undecay. Undecay means not alpha. Alpha beta is the one that is emitted from the decay molecule. The initial amount, initial nuclear amount. Then R is a radioactive decay. Lambda is radioactive decay. The radioactive decay means after the decay. The radioactive decay is alpha, beta, gamma. After it is disintegrated, that's alpha is a radioactive decay. Radioactive decay, lambda.
Not wavelength.
Not the wavelength. That is entirely different.
Okay, sir.
Or so the mean life is equal to lambda n0 0 to integration t e minus lambda t dt divided by n0. Mean life. Okay, mean life, you take this value, take this. Mean life. Total number of nuclei n0. Torque is, this is not torque, mean life. This is not the torque which you used in the Newton's law. This is different from this one. The symbol we use are the same, but the meaning is different. T of is half life of the nuclei. T of is half life of the nuclei. Over? Over? So uranium 238 is gives 38 234 plus 4 92 thorium 90 and 2. So 90 plus 2 234 plus 4 238. So from uranium I got thorium, I got plus helium, which is He2 plus 4, which is that is alpha. Not what is that? Alpha particle. Alpha particle. Then phosphorus 32, phosphorus to sulfide 16, phosphorus 15, this one is 16, this one is the beta, which is gamma radiation, alpha beta radiation, beta decay. Third is gamma. There is no definite mass. So what it is, it's a type of wave. It's a type of wave, gamma. So there is no equation for it. Or you can put here itself, gamma radiation plus gamma radiation, because it has no specific. No. It has no specific specific mass. It has no specific mass. So gamma radiation, that's all. Because here is alpha, here it is beta, here it is gamma. So this, which is positive? Alpha is positive. This one is? This one is? 0. So this is what I told you when it's in the alpha decay, radioactive decay. Positive, negative, 0. Nuclear energy. Nuclear energy. Nuclear energy is a process by which the energy is produced nuclear energy is the process by which the energy is produced from the change of the mass of its nuclei. So nuclear energy is defined as, what is that? Nuclear energy is defined as?
Nuclear energy is proposed by,
No. Nuclear energy is defined as
defined as
change in the mass of its
nucleus.
change in the mass of the nuclei to produce its corresponding energy. To produce its corresponding energy. To produce its corresponding energy.
So first என்ன சொல்லுங்க சார்?
Nuclear energy is nuclear energy is defined as nuclear energy is defined as nuclear energy is defined as change in the mass of its nuclei to produce its corresponding energy. To produce its corresponding energy. To produce its corresponding energy. Okay? To produce its corresponding energy. Okay, it's two types, fission and fusion. Fission and fusion. Fission and fusion. So what do you understand from the definition? What do you understand from the definition?
The
Change in the
mass of the nucleus will produce energy.
change the correct. Change in the mass of the nuclei. That is, what is the nuclei constitute?
Protons.
Proton and neutron. So if the proton and neutron that constitute the nuclei, the mass will change. If the mass is changes, means that led to the change in the that led to the energy production. That's all correct. So did you understand?
Yes, sir.
Change in the mass of nuclei means what is the mass of nuclei changes?
Proton.
The nuclei constitute. Okay, you can take here itself. Okay, here itself. What is a proton and neutron is made up of? Here, proton and neutron. Proton and neutron. So the proton and neutron is
90.
okay. You can keep as 92. Here, proton and neutron is.
90.
So how many? What is the change in the thing now?
Mass
It decrease in the mass. So that is a decrease in the mass. Okay, it led to the radiation. No, what it says that if the change in the mass, how the change in the mass led to the production, that we are going to see in the process, nuclear fission and fusion process. Okay, nuclear fission and fusion process. So you understood now what is the nuclear fission and fusion? This is one of the foremost example. See, I am taking uranium 235. I am bombarding with neutron. Nuclear. What is this process? Nuclear fission. Nuclear fission. First one we go for fission, then we go for fusion. Uranium 235. I am bombarding with neutron, which is N1. So it constitutes 235, 236. So 236. Now 236 will develop. 236 will develop. What is it? 140 barium and krypton plus 3 neutron. So what is the change of the mass here? 235 to 144 and 189. So 235 is
189, sir.
What?
89.
89. So 235 is converted into 144 and 89, by which you can see that 235 is converted into 144 or 89. So, this one you can take 92. 92 is converted into 56 and 36. So, the change in the mass of the nuclei, what is the change in the mass here now? Uranium change is converted into barium and krypton. So, the change in the mass of the nuclei will lead to the energy production. If this process happen, what will happen? It will produce lot of heat energy. So this is the process which is going in the Kalpakam. You know Kalpakam nuclear reactor, how many megawatt it is? 100 megawatt. So what is the process is going on there? This one, the same process, this one process, they will do it for 10 days, 10 times. This entire process will take 1 hour, and the production will take they will take for, I think, then from the output this will take few seconds only. Okay, the production they will continue for production of electricity, entire process they will continue for 2 to 3 hours. So one cycle completes for 3 hours, 24 hours is there. So how many cycle I can complete?
Once again, complete for 20 hours, sir.
Huh?
3 hours, one cycle.
2 hour, not 2 hour. Per day 24 hours, no, 10 2.5 hours you keep approximately. 2.5 means 10 into 2.5 hours. 10 into 2.5 hours. எவ்வளவு வருது? 2.5 hours into 10. How much you will get? 25. 2.5 hours into 10.
But, okay.
So total process is 2.5 hours. 10. That means how many times they will do it? How many hours is come totally? 25 hours. That means 25 hours constitute 1 day. So 1 day they will do this process for 10 times to produce the electricity. That's all. This is what electricity. Okay. What is the process involved? We are going to see now.
This one for fission, sir.
Fission. Nuclear fission. So this value, this term coincides with the definition. What is the definition say? Tells that change in the mass of the nuclei will produce the energy. That's all. Will produce its corresponding energy. So this will produce the what? Heat energy. This will produce heat energy. Okay. Okay. So what I told you, uranium is converted into barium and krypton. So when it's converted into that position, when the process is started, what will happen? It will produce the heat energy. Here the plenty of heat is there. Now I am passing the steam. Okay, passing this water. It will be converted into steam. This process, and you know, right, what is a hydroelectric process? Did you ever visit a dam? No. Water will flow from if they open the shutter, the water will flow. When the heavy water flows, they will produce current from that. How they will produce current from that? Or you from the speed of the water. Since dam is located very high, when they open the shutter, the water will flow with the high speed. So when you keep the fan blade, you know fan, right? Where it is fan? Yeah, fan is kept here. Okay, keep that fan. Okay, what is the difference between this fan and that fan? This fan you are supplying the electricity, so it get the current electricity and fan will rotate. But there, since water is flowing heavily, the fan will rotate. Or you can go to wind. Did you ever visit Madurai, something like that? You will see the turbine, very high turbine. We'll go to that example. You'll be seeing bigger turbine, very high height. In a very high height, you will see the turbine with the blade, with the fan blade. Well, what is that purpose? It will produce electricity. How it produces electricity? Due to they will not kept in the hour height. What is hour height? Feet. Obviously 5 feet. But how many height they will feet? How many height they will kept at the feet? How many feet it will be? What they kept? Yeah, 100, more than 100. So they kept in the 100 feet. You can imagine how tall it will be. So at the height, what will happen? Speed of the oxygen is very high. What it will do? Once the heavy hair will travel with very velocity. In that case, what will happen? It will try to rotate itself, because the turbine is since the speed, the oxygen, the hair speed is very high. It will try to rotate the fan. Yeah, once it start rotating, obviously the downstairs they will produce the current, because something is rotating it. That rotation energy is converted into electric energy. Something you have to give some energy they will getting. So some energy is getting from the rotation. That's the same principle here. Here what is here? Steam is there. Steam is coming in the this water. Water is going in the liquid state. Here it is. What is going in the liquid state? Here it is. No, here. What is here? Heat. Heavy heat is there. When the water is going in the liquid state, what will convert? It converted into steam. When the heavy steam it falls, what it will convert? The blade will be here. What it will do? No. Blade. Some blade is there. We have kept we kept in the highest height blade. That same blade we have kept fan. We have kept here fan. What will happen? That fan now? Fan will try to rotate. So the fan will try to rotate. So from that we can produce the electricity, and steam will come downward here. Once steam comes downward, it is in the which state? Vapor state. Vapor state is converted into vapor state will be converted into liquid state using coolant. That's all. So now we got now we having this electricity. Now we are having the nuclear power here. Here water is there. Water they will normally take from the sea water, because all the atomic nuclear power plant will be located in the sea solution only. Sea or near to river. You need millions of gallons of water here. So you can't get from groundwater 1 liter, 2 liter. You need millions of liters of water. So you have to pass the water here to convert it. Heavy energy is there. It converted into steam. So the steam will pass to the blade here. This is a blade. So it will try to rotate. The blade will try to rotate. From that the energy will be produced. That means this is a blade here. So fan blade, something like fan blade. So everything is one fan blade. Everything will produce automatically here the current. Okay, so the current will be distributed to the EB board. Okay. Now the coolant is here. Coolant will be kept here. Coolant will be kept here. So the coolant will cool the vapor, water vapor. So the water vapor is cooled means what will happen? It will produce the liquid in the things that will be sent out. That will be sent out. Water. So here it will be water outlet. Here it is water inlet. Finally, we got the electricity, but here it is. What is here? It is
Heat.
not heat, nuclear process. Okay, heat is there, nuclear process is going on. That generates the heat. So, first step is nuclear generator. First step 1 is nuclear generator. Step 2 is water inlet. Water inlet. Third, step 3 is, or step 1 we can put. Step 1 is water inlet. Step 2 is nuclear process. Step 3 is water steam water. Steam water. Okay. Step 4 is production of electricity. Production of electricity. Step 5 is water outlet. That's all. 5 steps. 5 steps explanation you have to write. Fission. Nuclear fission. Nuclear fission. Control rods. Rods. Over? Over? So now I am taking this. This is a control rod. Is there? No? I will ask one question now. Over? Over? Okay. Control rod is there. If I remove this control rod, what will happen? You understand my question? Huh?
It will not produce the heat.
Control rod. This control, what is the purpose of control rod? Huh?
Control the heat.
Huh? What is purpose of control rod?
Produce heat.
To observe the neutron. The purpose of control rod is to observe the neutron, excess neutron. Okay? Right. The purpose of control rod is to observe the excess neutron. The purpose of control rod is to observe the to observe the excess neutron. So how many neutron is that? How many bombardment? How many neutron we are producing it? How many neutron we are supplying for uranium 236, 235? The equation.
9-2.
Huh? How many neutron?
1.
1 neutron. So but how many neutrons we are getting now after the barium and krypton? 3. So we are supplying 1 neutron for 1 cycle. We are getting only 3 neutron. If I remove this rod, what will happen? If I remove this rod, what will happen? The number of production of neutron will be more. More.
Yes, sir.
If the number of production of neutron is more, what will happen? That's my question. Till now I didn't. Now only I am asking the question. I give all the explanation to you. Now what is the question? What will happen if I remove this rod? If I remove this rod, it will happen to that's why that becomes the atomic bomb. When I remove this, the moment I remove the rod, I am going to Kalpakam now. Okay? Now I am taking Kalpakam. Now it's almost 12 o'clock. Okay? 12 o'clock, it will take 2 hours to reach Kalpakam. I am going there. So I am removing the rod now. 2 o'clock, I am traveling for 2 hours. So I am going there 2 hours. I am removing this rod from the nuclear reactor. What will happen? That's all. It become atomic bomb. Entire Chennai will be destroyed. Chennai. This is the atomic bomb which was dropped from the, you know, right, 1945. The American dropped the 2 atomic bombs in Japan. What is the name of the bomb?
Hiroshima.
In Hiroshima and Nagasaki, in 2 places, Hiroshima and now Nagasaki, they dropped 2 bombs. That is this bomb, atomic bomb. If I remove this rod, what will happen? Number of production of neutron will be more. So that will lead to the chain reaction. The uranium will be continuously bombarded by the neutrons. We are supplying, how many neutron we are supplying here? 1. If I supply millions of neutron to the uranium, millions of neutron, I am removing the rod now here. I am removing the rod means it will not absorb any neutron. So the neutron is production will be infinity now. So what will happen? The neutron will bombard the uranium. Millions of neutron will bombard the uranium. So that's all. Entire channel will be destroyed. If you remove this rod in Kalpakam, if you go to Kalpakam and remove this rod, so that's all. The entire channel will be destroyed. It will become now atomic bomb. Okay. So the purpose of this rod is to observe the neutrons. Okay, you taken everything?
Yes, sir.
Everything you taken, no? Okay. nuclear fusion. So H11 to give H21 plus E minus 1. So E1, E positron. Okay? So H12 plus E1. So 1 and 1 plus 2. 1 plus 1, 1 plus 1. 1 plus 1, 2, here it is 0. So this is positron. So what is this? What is this one? This is what is this? Hydrogen. This one is? This is not hydrogen. This is a helium. Helium is entirely different. Helium is He. This one is deuterium, H12. Then this one is H12 and H12 will gives H13 which is tritium. So hydrogen, deuterium, tritium. So it is. So what is the example for this? So from hydrogen I am getting the tritium. What is example for this? Example, one example, that's all. What is example? See, this is nuclear fusion reaction, and this one is hydrogen produce the deuterium. Deuterium combines to form a tritium. What is example for this? For nuclear fusion. Example, one example, that's all. See, combining, that's all. This is the overall reaction. What is example? What is example? You taken this first. Did you take this? Okay, take this. Then you tell me the example. What is, you have taken this? Okay, what is example? Simple one example I am asking. Nuclear fusion means, what is example for this? Sun. Our sun, no? Star. Sun, star, all are example. What is going on? The process is going on in the sun. What is the age of the sun? What is the age of the sun? Age of the sun and the earth. 5 billion years. 1 billion constitute 100 crore year. So not 5 billion years, 4.5, okay, you can take it as 5 billion itself, 4.5 something, okay, you take it as 5 billion. That means what is the age of sun now? 5 billion years means how will you convert it into Indian unit? 500 crore years approximately. Not 500 crores, 450 crores something. So at the time when the sun born only, from that only earth born. Then from that only it took initially it took 4.5 crore, 450 crore years back when sun was born, earth was born. So then it took almost 300 crore years back something to cool it. It was it's one of the rock. Earth was actually a rock, Actually, Earth was rock, not Earth. Earth was when it separated from the sun 500 crore year back. It was rock, simple rock. Then it took 300 years to cool it. Then after 300 years, it attains the average temperature around 50 degrees, something like that. Average temperature reached. Then only the plate was then it Earth was almost 400 crore year time it took to cool it. Then after that, after 50 crore, then it some few crore years it took to form the then it took some time to get the water. Then only once Earth got the water, it becomes now it's become Earth to become life existing. So then DNA formation took almost 50 crore years before that. From today to almost 50 crore years back, DNA was formed in the sea. From there only the life begins. Then fish was formed. Then the fish amphibian was formed, which is fish. Fish can live in the water. Amphibian can live in the frog, which is can live in the land and water. So from that reptiles form. From the reptiles, humans, mammalians form. From mammalians, humans came. So the earth of the life is approximately 500 crore year, not 500 crore, 450 crore. So we can take it as 500 crore year. So what is the earth of life of sun now? Age of sun? Age of sun. Age of sun.
50 crore.
Huh?
50 crore.
500 crore, not 50 crore. 500 crore years back where the sun was born. When the sun was born, it's live from this today almost 500 crore year back. So what is the process going on? This is the process, nuclear fusion. This process is going on in the sun now for past 500 crore years. So it will live for another, how many, what is the maximum age of the sun now? Maximum age is 10 billion years ago. 10 billion years, total life is 10 billion years. In that 500, in that half of it, 5 billion years is over. Age of sun. Remaining is now 5 billion years. So another 5 billion years means what? Another 500 crore years. The sun will stay for another 500 crore year. So it has that much of hydrogen to fuse to give the energy. That's all. This is the trick. So nuclear fusion is nothing but sun is the example. Okay? That's all. This chapter ends. So 5 minutes break. இது மைக் ஆஃப் பண்ணுமா?
ஆமாம் சார்.
ஒரு 5 minutes
அதான் வந்தேன்.
சரி ஓகே ஓகே கிளாஸ் இருக்கு
இருக்கு பிரேக் தான்.